See how much you remember? So basically, we've already looked at asymptotes and things. When do we get an asymptote? But what does an asymptote mean?
You can get infinitely close to that value, but never get back.
Yeah. So it's actually not just about it not being that value, because we've seen before, haven't we, where that value might end up on a single value on a straight line, and you can't actually see that. So an asymptote is when we can get infinitely close to it, right? So specifically that. So we've looked at identifying values that cannot exist, and we've looked at the behaviour of rational functions, being fractions, and as the variable gets larger, what happens to the value of the fraction? If the variable gets infinitely large, the fraction gets infinitely small, because you're dividing something by a larger and larger number. So when we draw and label the asymptotes, we're kind of considering the values that it cannot be. So let's have a look at this first one. Would you already know? I've already set up. Okay. So here's my axes. So we know that this x cannot equal 0. So how do I put that in the graph?
It can't be anywhere on the y-axis.
Y-axis, okay?
Not like football. Maybe doing football.
So we've got an asymptote y, which is the y-axis, okay? What's the other one?
Oh, it's just zeros.
Can't be negative 4. Why can't it be negative 4? What can a fraction never equal? 0. So if a fraction can't equal 0, then y will never equal 0 minus 4, which is minus 4. So if I put my asymptote at y can never be minus 4, okay. Negative 4. X equals 0. If they sketch the function, well, all of these are based on just 1 over x, which means we don't have to be too specific in terms of where the curve goes, because we don't have to compare 1 over x to 2 over x and so on. So the shape of this will be, we go down, I'm going to pick that point to go to if I can. That is awful. Just to be consistent.
That's the asymptote.
Yeah, that'll do it. And then the same the other side. Nice and easy. Then it says state the domain and the range. What's the domain? X can be any real number. Cannot. And the range?
Same thing, but can equal -1.
Yeah, so y can be any real number. Y is not allowed to be negative 4. We've got 2 more. So this one is the same as this one, really, same sort of structure, but this one does offer something a little bit different that we've got to be aware of. So let's just go through that one.
Is v just going to be 4 and 0 because it's a fraction can never equal 0, then y.
Well, what can x not equal?
X can equal 4.
X can't equal 4. Yeah. So x is not allowed to equal 4 because the whole thing is not allowed to equal 0. So x minus 4 is not allowed to equal 0. So x equals 4 is an asymptote.
So would that mean then 0 is also the asymptote because that side, the right side will never be 0?
Yes, so the entire fraction. So it doesn't matter what x is, this fraction will never equal 0, which means y cannot be equal to 0. So therefore, in this case, we've got an asymptote that is that axis. Yeah? Draw my curve, making sure not to go over the asymptote. I mean, we all know it's a sketch, so it doesn't matter too much, but we have to make the point we're not touching the asymptote.
Get a really, really, really sharp pencil.
Yeah.
Infinitely sharp.
Infinite. Alright. Change then for this one. So the domain is x can be any real number, but x cannot equal 4 in this case. And the range at y can equal any number, but y cannot equal 0. Okay. No questions on those? Let's look at next type of question then, just doing things the other way around. Each of these functions has an equation of the form y equals 1 over. That's important in this case, because there's not going to be any terms of stretch involved. So 1 over x minus h plus k, find the equation of each graph. So the fact that it's 1 over is quite important. So in this case, we've got y equals 1 over. How do we identify it? We do the opposite to what we did before, which was we put in the asymptotes and then draw a graph. So this time we want to identify where the asymptotes are and what that means. So we've got an asymptote here which is at x equals 0. So that suggests under here is just going to be x. We've then got an asymptote y equals negative 5. So minus 5. Because that can't equal 0, so y can't equal 0 minus 5. That's easy. Try this one. If you just do it verbally, and then I'll leave it on the board for you to draw it out afterwards if you like. Just think about it first. What do you think?
Y equals x over 1 over x minus 2 minus.
So x minus 2 because. Yeah, because if x is 2, what makes 0 basically? So 2 minus 2 would make 0, so we can't do that. And then y being negative 7 means minus 7. Let me just check something, whether I've added anything else. I don't think that's all I wanted to go through with you as examples.